So hello everyone, today we are going to solve design task manager problem. There is a task management system that allows user to manage their tasks, each associated with a priority. The system should efficient and handle adding, modifying, executing and removing the task. Implement task manager class where you will be given a tasks 2D vector and each of these 2D vector consists of user ID, task ID and priority. You are given function void add where you have to add user ID, task ID and priority ID. So basically you have to add for that particular task. Void edit, you are given task ID and you have to change its priority. Void remove, you have to remove that particular task from the entire task list. And int execute top, exec top, you have to execute the task with highest priority across all the user. It is important across all the user, whichever process is having the highest priority you have to execute it. And it is mentioned that if two processes have same priority, you have to execute the process with higher task ID. And after executing, you are going to remove that particular problem and you have to return user ID of that particular task, which means which user has started that particular task, you can say. And it is guaranteed that task ID is unique, and while removal it always exists in our system. So let's go towards code. So let's talk about what we will be needing, what we will need. Since we have to maintain some priority, which means based on priority I have to sort you can say. So what I can do is I can maintain a priority queue of pair of int where the first value indicates priority, right, and the second value is task ID. So at this particular priority queue stop will have highest priority. If two are having same priority, it will consider based on second thing, which is task ID. So the highest priority process, or you can say task, will be on the top, and if two tasks have same priority, the task with higher task ID will on the top. And since we are going to edit our priorities, so we have to maintain a map of task and priority. This is one thing. And also we have to return task based on the top most prior task. We have to return user ID. So we also have to have our user task to user. So we need to maintain two map, or you can maintain in single map also, but I am using two map approach. So first map will be task to priority and the second will be task to user. So in the constructor we are given this 2D vector of tasks. What I am doing, simply taking the task and adding it. So I am taking this particular thing for auto task in task. I am passing this particular value in the add function. So what I am doing in add is I am assigning priority to particular task ID and user ID to particular task. And after that I am pushing priority and task ID, right? So in edit, what we are going to do is we are just simply going to update our map. What we are doing is task to priority, we will give task ID. So for that particular task ID, I am assigning new priority. And once I have assigned new priority, now my map, particular task priority map, is having the latest priority after updation. And after I have updated the thing, I am inserting new priority and task ID to my priority queue. Right, I am inserting priority and task new priority and task ID to my priority queue, so that I can maintain topmost prior task, right? So in remove, I am just simply erasing task priority. I am erasing task ID from task priority and task user. So here is the most important execute top thing. There may be a case you are calling execute top, but you have not given any task. So there may be a case priority queue is empty, which means there is no process. And whenever there is no process to execute, we are returning -1. There is another case. Once we have removed task, right? So there may be a case that priority queue stop consisting of that particular task ID which we already have removed. So what we are going to check? We are going to check first if the whatever task ID which is at the top, which means priority queue dot top dot second, is available in task priority. If yes, I am checking another condition. What is that? So there may be a case that let's say on the priority queue stop there is some process which is having priority 100, and let's say its task ID is 1, and now I am editing task 1 and giving priority to 50. So now its priority is reduced to 50, right? But the top still consists of 100 and that particular task ID. So if task ID exists in our map, which means the task ID is not removed, and if exists, I am checking the whatever priority I have at priority queue stop is same as updated value of priority. What I mean to say is task priority of pq.top.second. So the value, the actual value after updation, edit and all, the value of this particular thing, task priority pq.top.second is equal to whatever I am currently storing at priority queue. What it is pq.top.first. I am checking if data those two things are same. If yes, then it is all good. This is it. This is exactly what we want, right? If the priority which we are having at this particular map task priority and the value at priority queue does not match, which means the particular entry is false, so we have to remove. So what we are going to do, we are simply going to do pq.pop, and we are maintaining a while loop. So until this thing is not valid, I am just going to pop out things. After this while loop, there may be a case. Our entire priority queue becomes empty. If it becomes empty, as I mentioned, we cannot execute any process or task. So we simply returning -1, right? So this is completed. Okay. So now we are extracting the task ID of the priority queue.top. For that we are doing pq.top.second. Now we have task ID. We are removing the task since we have it is mentioned in question. After execution the task is removed. Okay, so now I am again checking. This won't be a case, but still let's check. This will never be a case, but for safety I am checking in task user if this particular user exists or not. If not exist, return -1. This case is never going to happen. If task priority does not exist, this clearly implies task user is also not exist, right? And based on that particular task ID, I am retrieving the user. And since after execution process is removed from our system, I am calling remove function with the particular task ID which I have got. And after that I am returning our user ID. So that is it, as you can see, right? So now let's talk about time complexity. It will be order of n log n. Let's suppose in total n task, entire calling and we are considering there are total n tasks and n. So we have to add all the tasks, and adding each task cost me log n log n. This is as simple as that, and we are certainly using extra space, so we have to calculate. It will be order of n or slightly greater than order n, but we can think asymptotically it is order of n. So yes, this is it. As you know, you can always access code from github.com, this particular URL. You have to find a particular folder and you can easily find this. And this is it for today. You can check out my profiles. I am going to add a link of my profile in the description. Thank you everyone.